So we were talking about indexes, right? And we talked about the types of indexes. We looked at B-tree, right? And then what was the other one? Hash index. Yeah. So these two based on the structure of the index. So based on the data type, right? So we saw unique index. Then we saw, we didn't see, but we said there is something called a spatial index. And we also have something called a full text index. So these two are specialized applications. Unique index can be used with all the regular data types, right? So like character, numeric and all that, right? So this is how, this is what we had seen. And then we saw how B-tree works, right? So it uses something called the binary search. And it builds what is called a balanced tree. Right. So it builds a balanced tree and uses the idea of binary search. Hash uses something called the hash function, right? We saw this is very fast, but then you can't use it everywhere, right? So only certain engines support it. Right. Then coming to unique index, we saw there are two ways of creating it, right? So when you say unique, you can create it implicitly without saying create index, right? So just by creating a constraint, unique constraint, right? This automatically creates an index at the back end. The second thing is make it primary, right? So make it a primary key. By default, this will become unique and not null. The other way is explicitly create, right? So we can use the create, explicitly create. We can use the create table command. Sorry, not create table, create index command. So the command we wrote down, create, and optionally, we will say unique or spatial, or what was the other one? Full text, right? And then index. Then we have to give the name of the index, right? So index name. Then again, optionally using hash or B-tree. And then on table name and column name, right? So this was the syntax. And we created an index on one table, right? And we saw that it made the search at least 100 times faster. So now, is it a good idea to always create an index, right? Because it seems like creating an index is making your search very fast. And we also saw that if you have a table like employee, right, you can create multiple indexes on this. You can create an index on employee ID. You can create an index on e-name. You can create an index on hire date, which we did yesterday, right? So multiple indexes are possible on the same table. So now what will happen is, if you remember the B-tree, right? So that B-tree structure, we saw this tree-like structure, no? Right? So this structure needs to be created and maintained. You remember we had to arrange the employee IDs in ascending order, right? And then we had to build the tree, not as this is how MySQL builds the tree, right? So you have 21, 23, 25, 27, 30, 32, 34, 36. So like this, you will arrange it in a certain order, right? And then you will build this tree. And what was the sequence of operations? Whenever you get a select command, right? So whenever you see a command, like not you, whenever the SQL sees a command like select, from EMP, where some column, right? So EID is equal to something. It will first check, is there an index created on this? If there is an index, it will go to the index. From there, it will find the record. It will find where it is stored. It will go directly to memory. And from there, it will fetch it, right? So if I have created multiple indexes on this, so there will be, see, if there are 8 records, we had this tree. So imagine if you have 1 million records, this tree itself will be quite big, right? So there will be 1,000 such decisions to make, right? At least 1,000 decisions to make if you have millions of records. So this will be a big structure depending upon the size of the table. So one, it takes memory, right? So memory will be used. The second is, the more important thing is, what if something changes, right? What if tomorrow somebody inserts a record called 24 here? Will your tree be still valid? Will this tree work if you insert a number here?
Yes.
Yes.
How will it work? You have to recreate it. Do you remember how we did this? We found the midpoint between these two. Then we found the midpoint between these two. So now if I'm adding a number here, the midpoint will change, right?
Yeah.
So here I have given exactly the midpoint, but let's say this is 23 and 28 here. So midpoint was something else. So now when I add a new record here, this changes. So based on that, these decisions will change, right? What am I checking? I'm checking for each midpoint after cutting it in half at every point. So if anything changes here, right? So let us say somebody updates this to 33. Again, the whole thing goes for a toss. You have to rebuild this index, right? So this structure needs to be rebuilt every time you do an insert, update, or delete. It's true for deletion also, right? If I take out this 27, again, my midpoints, everything will change. So the moment you do an insert, update, or delete, right, what will happen is your index becomes invalid. So internally, it will take care, it will rebuild it. But the point is, if you have a table, right, which is constantly being written into. So when you say written, write operation, we mean all the DMLs, right? So if there is a table, let's say there is a transaction table, which is handling all the transactions. Let's say it is keeping track of all the SMSs that are being sent, right, for a particular provider like Airtel. So per second, there are thousands of SMS being sent. So, so many records are getting added into the transaction table per second, right? So let's say this can handle 100 transactions per second. But then if you have created indexes on it, what will happen? Frequently, we are having to rebuild the indexes. Otherwise, having that index is meaningless, right? So because of this, this will actually slow down your system rather than help it, right? So the point here is, if you have a table where frequent writes are happening, when you say frequent writes, frequently you are doing insert, update, and delete, and rarely, right? So infrequent read operations. Read means select, right? So if you have frequent write operations into the table and infrequent read, once in a while you're using select. So in cases like that, this having an index is actually, it will reduce performance rather than improve performance. Also, imagine having multiple indexes on the same table. Every time you insert a record or delete a record, you have to rebuild all the indexes, right? Because everywhere it is going to change. So, so that is why creating multiple indexes on a table is not always advisable, right? So most of it will handle by itself. But if you have a table where you're frequently writing, right? So creating single index or multiple indexes will only reduce the performance. So when is it helpful to have a index? First thing, the table should have frequent reads. Okay. So let's say you have a table like employee table, right? And your employee, there are thousands of or lakhs of employees here. So in this table, frequently you will be looking up details about the employees. Once in a while you will add a new employee, right? So when we say infrequent, it could be like per hour you insert some records. That is fine, right? So here, once in a while, we'll do an insert, update, or delete. But the most frequent operation that you would do on an employee table is to read from the table, right? So we will be selecting from the table very frequently. And once in a while, we'll be writing into it. So in cases like that, creating an index is really helpful. And two, your table should be really large, right? So when we say large, you should have at least millions of records, right? So 3 lakh, 4 lakh and all is considered to be a small table if you have 3 lakh, 4 lakh records. So let's say you have more than this, you have around 10 lakh records, right? 1 million records, 2 million records. So in cases like that, you can create an index, right? Smaller tables, actually, this is just an overhead. It is a wastage of memory, right? And you are not, anyway, it is going to be reasonably fast. You won't see much of an improvement, right? But there will be cases where when you write your query, you will see that the query is hanging, right? It is taking too long to execute. So in cases like that, you will analyze the query, right? And you will see which all columns are you using to fetch the data. Then you can check is there an index on it? And based on that, you can go ahead and create indexes, right? Remember, every table should have a primary key. So based on anyway, the primary key will have an index by default, right? And mostly we will select records based on the primary key. Any additional indexes that you want to create, you should really analyze the query, right? If required, you go ahead and create it. Otherwise, don't do it. Right? It's not like, don't blindly create indexes thinking that it will improve performance. Right? And try to keep the number of indexes on a table to a minimum. Only what is absolutely required you can create. Okay. So this is it about your indexes. We have seen quite a bit, like we have looked at a lot of theory behind this. As far as the command is concerned, it is very simple, right? So we just say create index and all of this happens at the backend. But you should be aware of what is happening at the backend, right? Only then you will be able to efficiently create and use your indexes. Fine. Any questions in this? Anything with indexes? Can we move on? Yeah.
Yes, sir.
Yeah. Okay. So I think we are done with all the database objects. So what is pending is we need to go into programming, right? Stored procedures, and then we have window functions as well, right? How many classes did we have? Do you remember? We started on 23rd, I think.
8. Today's 8th class.
Today's 8th class. Okay. Fine. If required, we'll extend it by 1. Yeah, yeah, normalization. Right. Let's start with the stored procedures, right? So we will be moving into, is your Python done? You said no.
No.
Was it yes or no?
No.
Okay. Okay. So why do we need stored procedures? Right. So stored procedures are like adding programming to SQL. Right. Uh, if you see whatever we have done till now, we are running separate commands. Right. I'm doing a select. We are doing inserts, updates, right? But then there is no way to add some logic to this. What if I want to say, I select something, right? Based on the value that I have selected, sometimes I want to do an insert or I want to do an update. And based on whatever value I have selected. So things like this, if you want to do, right? So we need to have some kind of programming support along with the commands. So stored procedures is a combination of programming constructs, right? So when you say programming constructs, things like writing conditional statements, writing loops, right? Cursors and so on. Programming constructs, and then along with it, we will be using our SQL commands, right? So a combination of this. So that will make your using your SQL much more efficient for you, right? So you can do more complex things with stored procedures, things that you cannot do with separate single commands. Okay. So let's start with the stored procedure. So to do that, let's open the workbench. It is easier to do it that way. Open your workbench and then go to your database, DemoDB, right? Under that, you see stored procedures. So right click on this, click on create stored procedures, right? So the skeleton for creating the procedure will be given to you. So whatever logic you want to write, you have to write it between the begin and the end statement, right? So create procedure. Let me call this my proc, right? And then here you can write the body of the procedure, right? So we will just write a simple select statement here. I'll just say select star from books, right? We don't really need a procedure to execute a single command, but then we are learning how to create a procedure, right? So we'll say create procedure, name of the procedure, and between begin and end, we will say select, we will type the body of the procedure, right? Now, here you will see an apply button, right? So click on that. It will give you this and it will ask you to verify what you have typed, right? So if you're fine with whatever you have typed, click on apply. And if it is successfully created, right? So you'll see this green color button, right? So this means your procedure is successfully created. You can close this. Now on the left side, if you see, right, under stored procedures, you will see my proc has been created, right? I'll give you time to do this. For the moment, you just watch. Right, so the procedure has been created. How do we execute this? If you place your cursor on the procedure, you will see two buttons, right? One has the spanner icon, the other has this lightning button, right? So click on this and your procedure will be executed and you can see the result, right? This is one way. The other way is to type call followed by the name of the procedure, right? So we have already said use DemoDB. So we don't have to say that DemoDB dot. So you can just say call my proc, right? I can do it from here also. So I can say call my proc, open and close, right? Semicolon, and enter. So you can see whatever we wrote within the procedure has been executed, and you get the output here, right? Can you do this? Can you all create a procedure? Go to DemoDB, go to stored procedure, right click, create stored procedure, change the name of the procedure. Okay. Harshali says done. Let's wait a few more minutes.
What to do after stored procedure, ma'am?
Sorry, what to do?
Stored procedure then?
Here you are saying
Yes. Create. Yes. Done.
change the name of the procedure. And here you type the body of the procedure. So in our case, we have just given a single command here, select star from books, right? Okay. Fine. So I hope you're done with that. So now, see, this is something that MySQL automatically adds, right? So you can ignore that. You can leave it out. So now, so if you give a double dash and a space, right? So this means whatever you are entering here will be treated as a comment, right? So this will be treated as a comment. So MySQL will not try to execute it, right? It will not treat it as a command. It will just treat it as just a comment, right? So it will not execute. So if you want to comment out a particular line, I don't want to execute this, then you can give a double dash and a space, right? So now we don't have anything inside, no code is there, right? So this is a comment, double dash and a space, right? So if you want to print a message, if you want to say hello, for example, right? So the the command to use is a select command only. So I can say select hello as message. This is just a column name, right? Let me comment this out also, just to see how printing happens. So here I will apply this, close it. And now if I say call my proc, open and close, right? So you can see whatever you wanted to print has come, and this comes as the heading, right? So this can be anything. Usually we say message. You can call it greeting or anything you want to print, right? So this is the alias name for the command. So for what you're printing. If you don't give this, then hello itself will become the column name. Okay. Right. So this is how you can print an output from a stored procedure. Okay, so we know how to create a procedure, right? How to print something. So now what we will do is we will talk about variables. So whenever you learn any language, right? So when you start Python also, you will start with what are variables. What are variables, by the way? So if I say x is equal to 20, right? This x is called a variable, right? So this means you can think of x as a container to hold some value, right? So I can create a variable called my_address. And inside this, I can put my address. Right? So 123 First Main Road and so on. So a variable is a container, right? To hold a specific type of data. So when you say it is a container to hold data, you should also say what type of data can this container hold. What all data types are supported in MySQL? What all data types are supported?
Integer,
varchar,
Varchar, char, date, right? So if you're creating a container to hold a date, you have to first declare the variable, right? So declaration of variables is basically done to tell MySQL, see, I'm creating a container called X, right? But inside this, I will only put integer values. Or here I will say, see, I'm creating a container called my address. Inside that, I will put only varchar values, right? So first I have to do this declaration, and then only I can do this. I can put values into it, right? So the way you would declare a variable in MySQL is you will give the name of the variable X, and you will say this is of type integer. All right. So this is called variable declaration. So after you declare a variable, you can assign values to it. You can say X is equal to 20. So this is what you call assignment, right? Assigning a value to the variable. So hereafter, if you try to put something other than integer into X, MySQL will complain, right? So it will say, you said you will be putting only integers. Now you are trying to put something else, and I will not allow it. So these two things needs to be done when we are creating variables. Okay. A variable has a name and it has a value. And also we have to say what is the type of the data that you're going to put inside X. So X is a variable of type integer. Or you can think of it like X is a container that can hold data of type integer, right? And 20 is the value that is assigned to X. Okay. So now when it comes to stored procedures, there are two types of variables, right? So one is what you would call parameter, and the other is what you would call a local variable, right? So a parameter is used to pass values to a procedure. Local variables are used within the procedure, right? So this is used inside the procedure. So let's see this first, right? So here I have created a procedure called myproc, right? And in order to execute it, we said call followed by myproc, and open and close braces. So if you want to pass some value to the procedure, you can pass it here, right? So this is where you would pass a parameter. Let us say you want to pass a number, right? An integer value into the procedure. You will say call myproc, and within this, you will say x integer, right? When you are, no. When you are calling the procedure, right, you will say call myproc, and you can pass some number like 20, 30 and all. But if you want to do this, when you're creating the procedure, right? So how did we create the procedure? We said create procedure, name of the procedure, right? So myproc. So here you have to say, I will be passing a variable of type integer. Right. So now when you say call myproc of 20, x will be given the value 20. If you say call myproc of 30, x will be given a value 30, right? So this 30 can be used anywhere within the procedure, right? I can use x is equal to, sorry, if x is greater than 50, right? All those I can do, right? So let's do that here. So let's say, let me take this out, right? So I don't want a message here. Instead, I will say select star from books where book ID is equal to 5, right? So that is 6, okay, fine. Where book ID is equal to 6, right? So here we are not doing anything. What happens when I do this? I will apply this, right? Apply this. By the way, whenever you make any change, right? Whenever you make any change to the procedure, you should also always apply it. Otherwise, just typing is not enough, right? So whatever you type, you have to apply it, only then the procedure will be created, right? With the new code. So now when I say select star from books, where book ID is equal to 6, and I call myproc, right? So here when I called myproc, I got all the records, right? So now, because I made a change, if I say call myproc, only one record will be returned, right? So book ID 6 is being returned. If I want to see book ID 11 or 10, right? What should I do? I have to come here, make a change here, and then again create it, apply it, close it, and then you will call the procedure, right? So this is a very tedious process. Every time I have to go and make a change if I want to see a specific book. Instead, what we want is, I want to pass a number here, right? If I say call myproc of 5, I should see book number 5. Okay. If I say call myproc of 6, then I should see book 6. If I say call myproc of 10, then I should see book number 10, right? So if I want to do this, so what I'm saying is, I should be able to say call myproc of some number, and this number is of type integer, right? So when I create the procedure itself, I should say, see, I will be calling this, and when I'm calling this, I will be passing a variable of type integer. How do we do that? We come here, and we'll say, this is the definition, right? And here I will say X integer, right? So now when I say call my proc of 5, X will have the value 5, right? So this X I can use within the begin and end. So instead of this, I will write it as X. Will this work? When I say call my proc of 5, 5 will be placed on X, and that X is what you're using. So this is equivalent of saying select from books where book ID is equal to 5. If I say 7 here, 7 will be put on X. And because I have given X here, it is equivalent to saying select star from books where book ID is equal to 7. Right? So based on what I'm passing, my procedure will execute accordingly. So this is what we call a parameter. And it is used to pass values into the procedure. Is this right?
Yes, ma'am.
Yes, ma'am.
Okay. So let's change this. I'll change it to X. Let's apply this. Apply, close. And now I can call my proc and say 5. Right? I can say 6 here or 7 here. And I can say 10 here. So the corresponding book ID will be fetched, right? So this is what we call a parameter. Can you try this? Okay, Rani says done. How about the others? Okay. All right. So this is a parameter, right? So the next type of variable is what you call a local variable, right? And local variables are used within the procedure. So this is declared within the procedure, right? So somewhere between begin and end. Here you will declare a local variable and you can use it anywhere, right? So why do we need local variables? One is you might want to do some kind of intermediate operations, right? So you might have something like total salary. Let's say you have begin and end. And inside this, you want to store your result somewhere, right? So total is equal to salary plus bonus. So to hold these right values like total and all, you have to declare a local variable, right? So how do you declare? You will say total is of type floating point, right? And then you can use the variable total within the procedure, right? So this is not given here, right? Only a parameter is passed here. So this is what we mean by a local variable. So one reason we need local variables is to hold intermediate results. Like the sum calculations, right? If you're making some calculations and you want to hold the intermediate results into it, right? So then local variables are used. But more importantly, right, local variables are used to hold the values of columns. Okay. So here, let us say, whenever I pass this thing here, what do I get? I just get this record, right? I am just getting the record corresponding to book ID 7, right? But let's say I want to say something like this. If I pass 7, right, I want to say, or if I want to, if I pass 10, I want to say Emma was written by author 6. Okay. So Emma will be there in the title, and author ID will be 6 will be there in the author ID column, right? So I want to say whatever title we are fetching was written by whatever author ID we have, right? So this is how you will print this. So you will use the concat function. Concat is used to attach all these together. So whatever title is selected by our query, what is our query? Inside the procedure, we have select, instead of star, let me write it as book ID, title, and author ID from books where book ID is equal to X, right? So this is what we had. So if you pass X is equal to 5, title will contain night without end. AID will contain 5. And what do I want to print? This title, right? So night without end was written by AID. What is AID? That is 5. So next time when I pass X is equal to 10, right? So what will I get? Book select where book ID is equal to 10. So title will contain Emma in it, and author ID will be 6. So here this will print Emma was written by author ID 6, right? Is this fine? This is how it will work. Are we clear about what we are trying to do? We don't want to see the output like this. Instead, I want to see this was written by this author ID, right? I don't want to see the record here. How do? I just print it out, right? So I say select, concat this. Is this fine? Are you following? Or yeah, let's write it. So here I will select title and author ID from books where book ID is equal to 6. Now what I want to say is, I want to say select concat title, whatever title we selected here was written by, right, whatever author ID we have selected here, right? This as message. This is what we want, right? So let's see if this will work. Apply this and close it. And now if you call my proc of 10, it is selecting Emma and 6, but here next line it says title and field list is unknown, right? So you are getting an error here. At this point, right? So you are getting an error. It is saying, I don't know what is title. So the reason it is saying that is because, see, here it is fine, right? So here we are saying select title and AID from books. So MySQL knows that title and AID are columns in this table called books, right? But when you come to the next statement, here it doesn't know what is title. It doesn't know what is AID, right? Here it makes sense because we are saying select this from books. But once it comes out of the select command, MySQL will not know what these variables are. It will say, I don't know what is title, what is AID. There are plenty of tables in the database. There are so many columns. I don't know what is this title, right? So if you want to use the value of title somewhere else, if you want to do something like this, right? So what you have to do is you have to store these in what are called local variables. So I will declare a local variable to hold the title. I'll declare another local variable to hold the AID, right? How do we do the declaration? We'll say declare, right? For title, I will just create a variable called local underscore title, right? And this is of type. What is the type of title?
Varchar.
So I can say where care of some 50, right? So this is my local variable, and this local variable I have defined to hold the value inside title. Then I need another local variable to hold the author ID, right? This is of type integer. So now here, when it comes to this, we will say select title and author ID, right? Into local underscore title and local underscore AID. So whatever was selected in title will be stored in local title. Whatever was selected in AID will be available in local AID. So here, instead of using column names, I can say whatever is there in local title was written by whatever is there in local AID, right? So this will work now. So let's apply this, close it. And now if you execute this same command, you can see Emma was written by 6, right? So maybe I should have said author 6. Emma was written by author 6, right? So can you see why we need this local variable? Right? Because there is no point just selecting, right? So the reason we said we want the stored procedures is based on what we are selecting, we want to take some action, right? For example, you might be selecting the salary of a person. And then after selecting it, you might want to check if the salary value is greater than something, do something, right? But then I cannot use salary outside my select command, right? I can select salary, but this I cannot use outside of the select command. So what I will do, I will store it into a local variable, right? And that local variable I will use for further processing. Okay. I hope this makes sense, right? Are we fine with this?
Yes, ma'am.
Can you try it out? So now let us see how to use if statements, right? So how to write conditional statements. Conditional statements. So to write for conditional statement, you have the if statement, right? So we want to execute a part of the code only if certain conditions are satisfied, right? So if you open, this is there on your LMS also. So right. So you normally, right? So this is how the your code would look like. So your procedure will start here, right? There will be some declarations, and then you will have statement 1, statement 2, statement 3. So normally speaking, it will execute one statement after the other until you come to the end. But then there might be certain part of the code you want to execute only if certain conditions are satisfied, right? So that is where your if condition comes in. So we will say if this particular condition is satisfied, then execute these 3 lines of code. If this condition is not satisfied, then don't execute these, right? So go directly to the next set of statements, right? So if condition is true, execute this and come here. If condition is false, ignore this and come here, right? So if this evaluates to true, you will execute 1, 2, 3, 4, 5, 6, 7, 8, 9. If this condition evaluates to false, you will execute 1, 2, 3, and 7, 8, 9, right? So this is the format. You will say if some condition, then what all you want to do. And this should be followed by end if, right? So that is how MySQL will know these are the set of commands which belong to this if condition, right? You can also say what to do if this condition is not true, right? If it is not true, what to do, you will write it as a else statement. So if this condition evaluates to true, then execute these set of commands. If this evaluates to false, then execute these set of commands. So the whole thing is called one if statement, right? It starts here and ends here, right? So now what we will do is we will write a simple if statement, right? Nothing complex. So what we will do, we'll write a procedure. We'll create a new stored procedure. I will call this if underscore proc, right? And here I will say, I will pass a variable x, which is of type integer. So what I want to do is, if the number I'm passing is a positive number, I want to say positive, right? Otherwise, we will say negative, right? So we'll say if, how do you write the if statement? You will say, if the value in x is greater than 0, then what is it? This is a positive number, right? So we'll say select positive as message. Otherwise, right? So how do we say otherwise? We will say else. What should we say? We will say select negative as message. Negative. And then don't forget to close it by saying end if, and then a semicolon, right? So this is where your if statement is ending. So now whatever number you pass, if it happens to be positive, right, it will say positive. Otherwise, it will say it is negative number, right? So let's apply, close it. What is the name of the procedure? If underscore proc, right? So I will say call if underscore proc, and then I will pass a positive number here, and this should say positive, right? If I pass a negative number here, it should say it is negative, right? So this is how you can write your simple if statement. Can you do this? Done.
Yes, ma'am.
Okay, others are doing. Is anybody facing any issues?
Done, ma'am.
Okay. Right. So now I want you to do something, right? So I want you to combine your if statement and, the idea of local variables, right? And you go to the table called cats in your database. You say select star from cats, right? So you see some cats and you have some weights also, right? So here what you will do is, if the weight of the cat, right? If the weight of the cat is greater than 4.5, you will say chubby cat. If the weight of the cat is less than this, right? So you will say skinny cat, right? So write a procedure, right? So let's give it a name, if underscore example or something, right? So this, or let's call it fat cats, fat underscore cats, right? So this is the name of your procedure. You should pass the name of the, or We don't have anything else. Okay. Pass the name of the cat, right, as input. So name of the cat should be passed as input. And if that cat happens to have a weight greater than 4.5, you will say chubby cat, right? So this cat, let's say Ashes is a chubby cat, right? So if you pass Tigger, for example, here, if you call this with Tigger, it should say Tigger is a skinny cat. Can you try this? Right, so you should create procedure fat_cats. What should be passed as a parameter here?
Name varchar.
Name. Don't give the same variable name, right? Give some other name. Don't give name as the variable name. So you can say C name or something, right? And this is of type varchar of some 20 or something. And within this, begin and end, you will select weight from cats, right, where name is equal to whatever you're passing here, right? So now you have to check for the weight, but you cannot directly use weight outside this, right? So you can't say if weight is equal to, right? Because weight is a column. So what you need to declare a local variable, which will be of type integer. Select weight into local weight. And if local weight is greater than 4.5, you will say chubby cat, right? Can you try this? Take some time, try it. I think some of you have already written. So we will create a procedure. And we'll call it fat_cats. And we want to pass C name, right? So this is somewhere care of 20 or 30, right? Now here we want to select weight from cats where name is equal to whatever we are passing here, right? So name is equal to C name, right? But then I cannot say if weight is equal to, if weight is greater than, right? Because weight is only understood inside this select command. So what I should do, I have to declare a local variable called local_weight, right? Which is of type integer. And then this weight, I have to select it into local_weight, right? From cats where name is equal to this. Now I can check if local weight is greater than, let's say, or equal to, right? It's greater than or equal to 4.5, then we will print this, right? So we'll say select concat C name is a chubby cat, right? As message. Otherwise, we will say select concatenate C name, and we will say is a skinny cat as message. And end if, right? So let us see. create this, apply, close. And now let us say what all names are there. Okay. So we will say call cat underscore cats, and we will pass ashes, right? So it says ashes is a skinny cat. Is it a skinny cat? This should have
No.
been fat cat, no? Then let us see. Let's try something else. Let's try Felix, right? Felix. Felix is a chubby cat. So why is this not greater than or equal to not working?
Looks like it's working for greater than but not equal to.
Yeah. Let's try here. It says true. So greater than or equal to is working. Okay. Let us see here. Select local underscore weight as weight. Let's see what is there in local weight. It's not selecting. Should not. It is giving the weight as 4.
Should we declare it as float instead of local weight int? Can
Oh,
we
yeah,
declare
yeah,
it?
that is right. That is right. You're right. That should be a float, not an integer. Yeah, now it says this is a chubby cat. Okay. Yeah, that was a floating point value. So it is truncating and taking only 4, right? Okay, so hopefully we know how to use local variables, how to use the if statement. Actually, there is yeah. Right. So actually there is one more thing that you can do with the if, that is instead of checking for only this, when this is true or this is false, you can check for multiple cases, right? So you can check if, let's say marks, for example, right? So if marks is greater than 60, then first class, right? Otherwise, we have to check if marks is greater than 50 but less than 60, right? Then second class. Otherwise, if marks is greater than 40 but less than 50, then do something else, right? So if you want to check multiple conditions, right, not just this or something else, then you can use the else if command. Right, so you would say if marks greater than 60, right? So let's write it. Let's see how the else if statement looks like, right? So your else if looks like this. So the whole thing is your if statement. This whole thing is the if, right? So if some condition is true, then execute this. If this evaluates to false, then go and check the next condition. If this also evaluates to false, then only go and check the next condition, right? Wherever you find that the condition is true, you will stop there. You will not continue anymore, right? So in this case, the first condition itself is satisfied, right? So this evaluates to true. So this will be executed. This whole thing will be ignored, right? And then you continue with these statements. Here, the first condition evaluates to false, right? Only then you will come and check the next condition. So this also evaluates to false. Only then you will come to the third condition. So this happens to be true. So these statements will be executed. All of this will be ignored. Then you will continue with these statements. When do we come to else? Only if all the conditions evaluate to false, we will come to the else part. Right? If none of these cases are true, you will come to else. Right? So let's write a procedure which takes marks as input. Right? So we will create a procedure. Create procedure. And we will call it grades. And here I will pass an integer value corresponding to marks, right? So inside this, I will say, if the value of x is greater than 60, or let's say greater than 80, then we will print distinction, right? Else if, remember there is no space between else and if, x is greater than 60, right? And x is less than 50, less than 80, right? Then we will say first class. Else if x is greater than 50 and x is less than 60, we will say second class, right? Else we will say fail, right? So that means if x happens to be less than 50 also, we will say fail, right? And don't forget the end of. Can you write this as a procedure and see if it is working? You guys done? Should I write? Okay, so we'll create a procedure, call it grades. Yeah, that seems fine, right? We will pass x, which is integer, and we'll say if the value of x is greater than 80, then we will select distinction as grade, right? So let us give it grade. Else if x is greater than 70 and x is less than 80, then we will say select what is it? First class. First class as grade. Else if x is greater than 60 but less than 50, right? We will call it second class. Anything other than this, right? Else we will say select failed. Failed as grade. And so let's apply this.
Ma'am, there is a small error, I think so.
What is wrong?
X is less than 70, we can make it where X is greater than 60 and X is less than 50. No, there instead of 50, it has to be 70.
Okay, some number.
Yeah, because the condition is not greater than 60 and it can't be less than 50 in the second statement, ma'am, not there. In the second else if greater than 60, else in the second else if
This one.
greater than 60 is fine, but that can't be less than 50 again.
All right. This should be less than 70.
Yes, ma'am.
I'm not all there today.
Totally understand happens.
Yeah, let us apply this. Apply and close. Let's call grades. And let's pass some 87. So distinction. If I pass 67, it's second class. If I give something like 58, it's failed, right? So is that what we give? Yeah. Anything less than 60, we are saying failed. Okay. So this is how you can write your multiple else if statements. So we have seen how to write conditional statements, right? So we have seen the different what are variables and two types of variables, parameters and local variables, right?